how does the request work? So here is your laptop. Here is my School of Engineering site with a server. So this is a School of Engineering, but inside it there is a server that has a port 443 safe, because my request is going to be encrypted. And so I'm going to ask it for a page, and the page I'm going to ask is the root page, and so the URL is composed of the following portions. There is HTTPS, this is called the schema. It's which kind of protocol I want to use. In this case I want to use HTTP encrypted. Then the request will contain www.soe.ucsc.edu. This is called the host, okay, which is resolved to an IP by DNS. And then there is the URL, which in this case is very short, right? This is my URL within the host, which is just a slash because I want to have the root site of my School of Engineering. So how do I transmit this request, and how is the reply gonna flow back to me? The protocol used is incredibly famous. I'm sure you have all heard of it. It's called HTTP. The HTTP protocol is the Hypertext Transport Protocol. So we have, these two standards, HTML, which is the hypertext markup language, is the language in which you write a page, but the page needs to be transported. There needs to be some format, some way of sending it from the host to the client. And there has to be also obviously some way for you to request which page you want. And there is a lot of side information that goes with that request and the reply. The HTTP and HTML protocols are part of the initial specification of the web, what Tim Berners-Lee created at CERN when he was working on the early web. So how does that work? The request and the reply are encoded via this protocol that is called HTTP. There are various versions of it. I think the one most common right now is the 1.1, but actually, rather than going through the theory of it, what is most interesting for us is to see it in action, which is actually quite easy and pleasant, and you need to do it a lot in this class. So you take your browser, but what I do all the time is that I click on Inspect Element. This opens the website inspector, okay, and you have many tabs. You can inspect the content of the page, which we have been doing sometimes already in the past. There is console, debugger, this we will see, but let's look at network. There is a bunch of requests that are used in order to serve me the web page. But the first one is this. You see, for the URL that consists simply of a single slash. Then once that URL is fetched, which contains the main content of the page, there are also many other requests that are needed in order to load additional components such as images, CSS files, scripts, and whatever to build the full page. Let's not worry so much about these other requests. We can look at them later if at all. Let's look at the original request in more detail. So this is the main part of the request. You're doing a GET request for this URL. And if you click here, I think it will even split it for you into scheme, host, and file name. These are the components of the GET request. Okay, so there are various types of requests. The most important for us will be GET, POST, and PUT. Okay, the GET requests, which are the ones we worry with first, are the requests that are done in order for you to ask some material to be delivered to you. So the request has a version of the HTTP protocol, which is used, to decode the various headers, and it has a status code which tells the requester whether it was successful or not, or what happened. There is a list of status codes. 200 OK means, I think we can click here. Oh yeah, it sends me to the documentation. This is really actually nice. So 200 OK is a successful request that was replied with content. Okay. Funny enough, it tells me the response before the request, but I want to look at them in the right order. So these are called the request headers. It's like, what you would put on an envelope as your request information. Let's look at the main ones. You tell it which host, which is not so important. This user agent tells you which kind of browsers you have. I'm not sure that I want to go over every single header. They're also very well documented if you search for them. This means that you accept your reply to be encoded via gzip, which is a compression program, so that it makes it shorter. And very importantly, you also send it a cookie. Okay, we will come to cookies later. I want to spend quite some time on cookies and how to manage them. But let's look at the reply a moment. The reply says things such as the content type is text HTML, using this character set for encoding of the text, and then it contains a bunch of other things. I think, I prefer to go over these on a per need basis, but notice how nicely documented it is. If you're wondering, for example, what transfer encoding chunked means, you can click on it and this gives you the documentation. This is really very nice. The particular version of Mozilla I'm using, maybe it's provided by all of them, but this is the Mozilla Developer Edition. So I can look at the request, which is empty. There is no special parameters. These are the parameters, and then I can look at the response, which is, the page. I can preview it, or else I can look at the payload. The payload is just the raw page as it was served to me. And of course, being able to look at the raw response is very useful in debugging. Here I'm going a little bit fast, but I think throughout the class we will be looking quite a bit at these network traces, when we request a page and get a reply, because looking at them is one of the main ways in which you do the debugging. If something doesn't work in your site, very commonly you want to see what did you ask for and what did you get in reply, obviously.